Today what we're going to be learning about is Pythagorean Theorem. How many of you guys remember learning about Pythagorean Theorem last year? Okay, good. Okay, so Pythagorean Theorem is another way to find the length of a segment or the distance between 2 points. Okay. Typically though, like you'll see Pythagorean Theorem being used a lot when we have triangles. And there's a specific kind of triangle that it works for. Does anyone remember what kind of triangle? Right triangle. Okay, so yes, it's when we have a right triangle. Okay, do you guys remember what exactly a right triangle is? Okay. Yeah, it's when one of the angles is exactly 90 degrees. Okay, that's what this word right means. Okay, it means that one angle is exactly 90 degrees. Okay, now when we're dealing with our right triangle, we have, obviously there's 3 sides in the triangle, but to be able to specifically like label them, they're called either legs or hypotenuse. Okay, and the hypotenuse, do you guys remember what makes the hypotenuse special? Okay, it is the longest side of the triangle. Okay, it is also across from the 90-degree angle. Can you guys say that word, hypotenuse? Okay, so hypotenuse is the longest side of the triangle across from the 90-degree angle, okay? So, for example, if this were my 90-degree angle here, my hypotenuse would be directly across, so this would be your hypotenuse. Okay, so if I told you that in these other 2 triangles, the 90-degree angle was here and the 90-degree angle was here, then where would the hypotenuse be? Across from it, right? Bless you. Okay. Now, the other sides are what we call the legs, okay? And the legs are the 2 shorter sides in the triangle. Okay? And in a right triangle, the legs form the 90-degree angle. Okay, so in each of these diagrams, right here, this would be a leg, and this would be a leg here, right? These 2 sides are forming, or creating, they're touching to create the 90-degree angle. They are both shorter than the hypotenuse. Okay, so are there any questions about that? Okay, so one of the things you guys probably do remember from last year is the formula that you use for Pythagorean Theorem. Do you guys remember what it is? What is it? You guys remember? a squared plus b squared equals c squared, right? Okay, so what do the a and the b and the c represent? Okay, these two are representing the length of each leg. Okay, now, those lengths may be the same, they may be different, it depends on the triangle. Okay, but these are representing the length of each leg. Okay, the C term is representing the length of the hypotenuse. So all of these variables represent a length, okay, but depending on what letter, like the C term is the most important term that you label correctly because that represents the hypotenuse, okay, which is the longest side. All right, so let's take a look at some of these examples, okay. I don't know why in the printing it didn't print where the right angle was. You kind of need to know that in order to do the problem. So I want you guys to draw in where these right angles actually belong because the printing didn't come out. So those should be here, here, here on those problems. And then in the bottom should be here, here, and here. I don't know why they didn't print out, so just draw them in. Okay. All right. So here's what we're going to do. We're going to go ahead and use this formula, this a squared plus b squared equals c squared, to solve these problems. Now, the most important part is you identify where is the hypotenuse first. So, are 3 or 4 the hypotenuse? The missing side is the hypotenuse, right? We're going to call this side C. Okay, now, for your legs, does it matter which side I call A or B? It doesn't matter. You can change it around. As long as they're both legs, you can call them A or B. So let's just call this one A and we'll call this one B. Okay? So now what we're going to do is we're going to go ahead and we're going to plug in these things into our formula and solve for the missing side because it's asking us to find the missing side. So we're going to do A squared, so A is 3, so 3 squared, plus B squared, B is 4, equals C squared. Okay, now we're just going to evaluate this and then try to solve for C. So what's 3 squared? What's 4 squared? Okay, I can add these. What's 9 plus 16? Okay. Now, this says a number squared equals 25. So is this telling me that this side is 25? No. It's telling me this number squared makes 25. So what number squared makes 25? 5, right? 5 times 5 makes 25. So C is equal to 5. Now, the other way you can think about this is, remember in the warm-up the other day, we talked about what operation undoes squared. Like, what's the inverse operation of squared? Square root. So we can also take the square root of both sides, and squared and square root are inverse operations, so they basically like undo each other, cancel each other out, right? So I get the square root of 25 is 5, and so that's my value of C. Okay, now, I know when it's a perfect square number, it's easy to think backwards, like what number squared makes 25, so the answer must be 5, right? But when we get into some larger numbers, like say you got a number like 721, okay, you're like, what number squared makes 721? Like, your brain can't really process that, right? And so that's when we take the square root, and then we use our calculator to help us. Does that make sense? Okay, so let's take a look at this one here. Okay, the missing side, is it an A, a B, or a C? Okay, you guys try to solve this one right now. See if you can solve it and set it up. Check with your partner when you're finished. Okay. Okay, so let's go ahead and check your work. How many of you guys got 10 for your answer on that one? Okay, good. All right. Any questions on how we did that one? Okay, try the next one. So take a minute and try the next one with your partner right now, please. Okay, so go ahead and take a look at that one up there. How many of you guys got 13 for your answer? 13? Okay, cool. All right, so any questions on those ones so far? Okay, let's take a look at the next one. Okay, on the next problem, the missing side. Is the missing side still a C? What is it? It's a leg, so does it matter if I call it A or B? No. Okay, I can call it either one. I'll just call it A. Which one is actually the C? 17. So then this one will be B, right? Okay, so when I go to solve this one, I'm going to have A squared, not filled in with a number, right? Plus B squared equals C squared, which was 17 squared. Okay, now I'm going to work through solving this. So A squared plus 64 equals, what'd you guys get for that? 289. Okay, now ideally what I want this not to be here because I want to take the square root of both sides, right? But right now that 64 is there, so I have to get rid of it first. So let's subtract it by doing the opposite operation to both sides of the equation. Okay, so what do you guys get when you subtract that? 225. Okay. And now can we take the square root of both sides? Now that A squared is by itself, we're going to take the square root. Take the square root. So if you don't know this one in your head, use your calculator. Okay, what do you guys get for that? 15. Okay, so we get A equals 15. So there's our answer. Okay. All right, what I want you guys to try right now is I would like you guys to try the last two problems. And you can work with your partner or check with your partner when you're done. Okay, I'll give you a few minutes to work on those. Okay, so let's go ahead and take a look at your work. Okay, for the second one, did you guys end up getting, after you subtracted 40 and then taking the square root? Okay, did you guys round to the 10th place? Okay. If you take the square root and you have to round, you're just going to go ahead and round to the 10th place, so one number after the decimal, okay? And then this one ended up being nice and perfect. You should have got 7. How many of you got the last two right? Raise your hand if you did. Okay, good. Okay, let's go ahead and flip over to the back. Okay, so on the back, we've got some word problems. Okay, in the word problems, the most important part is to draw an accurate picture to help you solve it, okay? So probably the hardest part of the word problem is reading and interpreting what it's saying here and then drawing a picture from this. Once you guys draw the picture and label it, it's not hard to actually solve it, okay? So you just need to draw it correctly, all right? Okay, so let's take a look at this first problem. It says the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? Okay, so what do you have going on in here in this problem? What are they talking about? You've got a ladder. It's leaning against a wall, and it's also resting on the ground. Does that make sense? So let's draw that. Here's your ground. Here's your wall. And your ladder is sitting on the ground leaning against the wall. So the ladder is going to look something like this. Okay. Now, we know we've been working with right triangles, so where do you think the right angle belongs in this picture? What two things are forming the right angle? The ground and the wall, right? If the contractor did his job building the wall correctly, this should be at a right angle, right? The wall should not be slanted. It should be at a right angle. Okay? All right. So now, let's go back and look at the information that they gave us. They told us the bottom of the ladder is placed 3 feet from the wall. Where is the bottom of the ladder? Here or here? Yeah, the bottom of the ladder is down here. So that's going to be 3 feet from the wall. So we're going to label this part 3 feet. Okay, now it says the ladder is 12 feet long. Okay, so which part am I going to label 12? The ladder itself, right? So that's over here. That's 12 feet. Okay, and then the question says, how far above the ground does the ladder touch the wall? So here's the ground. It wants to know how far above. So it wants to know that distance. So let's call that one of our variables. Okay, should that variable be a A or a B or a C? A or B, right? It doesn't matter, but is it a C? No, it's not the hypotenuse, right? Because the hypotenuse is over here. Does that make sense? So I'll call mine A. I'll call this one C, because I know that's the hypotenuse. And then I'll call this one over here B. So now that I have this diagram drawn and labeled, now it's easy to do the problem, right? So you guys go ahead and solve this really quickly, okay? And then check what you get with your partner. Now, when you're done solving it, if you had to round to the 10th place. And then also, make sure in your answer you include a unit of measurement. Because does it actually give you a unit of measurement to start with here? What's your unit of measurement? Feet, right? Okay. All right, so go ahead and check your work. How many of you guys got it correct? Raise your hand if you did. Okay, nice. Okay. So we're going to do one more of these word problems. We're probably not going to have time to do all of them on the back. So there's one about a TV. There's one about a square. There's one about a girl and her shadow. Which one do you guys want to do?
TV, shadow.
Okay. Who wants TV?
Shadow.
Who wants shadow?
Shadow.
Okay, we're going to go with shadow. Okay, so let's take a look at this problem right here. Okay, so in that problem right there, it says Ruby stands at 5 feet tall. Her shadow is 6 feet long. How far is it from the top of her head to the end of her shadow? Okay, so we want to draw a picture of this. We've got a girl. She's standing, and there's her shadow. Now, to put this in perspective, when you are standing outside in the sun, where's your shadow? It's behind you, but where? Maybe it's behind you, but where is it behind you? Is it like floating around in the air? Where is it? It's on the ground, right? Okay, so let's draw Ruby. And she's like a giraffe, right? There we go. All right, there's Ruby. And she's standing on the ground here, right? And let's draw her shadow. So her shadow's like on the ground here. Something like this, right? Here's her shadow. Okay, so we've got her shadow, we've got Ruby. Let's label the things we know. How long is her shadow? How tall is Ruby? Ruby is 5 feet. What about her shadow? 6 feet. Okay, what was the question asking us? Okay, how far from the top of her head to the end of her shadow? So the top of her head's here, and I'm going all the way to the end of her shadow, which would be over here. So like from here to here, right? That's what I'm trying to find. So this is my variable. So if that's my variable, that's the missing one. Is that an A, a B, or a C?
C.
It's a C, right? So this is my missing one. The other two parts, because like where is the right angle in this picture? Yeah, by her toes, right? It's her with the ground or with the shadow, right? It's creating the right angle. So these two are your A and your B. Does that make sense there? Okay, so you guys try to go ahead and set up the equation now that we've got the picture and see if you can solve that one. Check with your neighbor when you're done. Include your unit of measurement in your answer. Okay, were you guys able to solve it correctly?
Yes.
Who got it right? Raise your hand if you did. Okay, cool. Okay, so those are the word problems. Okay, we're going to save the other two for like warm-ups. Maybe we'll do them tomorrow in the warm-up. Okay. Let's take a look at the last type of problem, which is determining whether a triangle is a right triangle or not. So I want to look at these last problems down here. Okay, we're going to do these two. Okay, and we'll save these ones for the warm-up. So don't do these. Okay. All right. So it wants us to determine whether or not this is a right triangle, okay? In order to determine which side of these is the longest, okay, we would normally look at the numbers, right? But this number is the square root of 170. It's not actually 170, right? So maybe what I want to do is to put that in perspective. Maybe I want to take that square root with my calculator and see, like, what is that close to? 13.0, right? So is that the longest side? No. And then this one's square root of 86, which is even less than this, right? So which side is going to be the longest side here? 16. Okay, so if this was a right triangle, this would be the hypotenuse, right? So I'm going to go ahead and call this the C, and then the other two can be the A and the B. Now, I'm not sure if this is a right triangle. What I'm trying to do is decide whether it is or not. So what I'm going to do is I'm going to plug in all of these numbers into my formula and check if the two sides of the formula come out to be equal. If they are equal, that means it's a right triangle. If they're not equal, that means it's not a right triangle. Okay? So let's plug this into a squared. So we're going to do the square root of 86 squared, because that's a, right? Plus b squared, so the square root of 170 squared equals c squared. So equals 16 squared. Okay, now we talked about in the warm-up how squared and square root undo each other because they are inverse operations, right? So what's all that's left from this expression? 86. Okay, what about from this one? The square root and the squared undo each other. So 170 is all that's left there. Now, do you actually need to square 16 and figure out what that is? Yeah, what's 16 times 16? 256. Okay. All right, so now we're going to add this side and see if it adds up to be the same as this side. So what's 86 plus 170? 256. Okay, so does that check out? Are the two sides equal? Okay, so your answer is yes, it is a right triangle. Now, what if in this problem, instead of square root of 86, I had square root of 96? And then I had 96 here, and then I had 266 here. Would that be right triangle? No. Okay, so if you get two numbers not matching up, not equal, that's not a right triangle. Okay? All right, so let's look at the next one. The next one didn't give you a drawing, it just gave you some numbers. Okay, none of the numbers are in square roots, so it's pretty easy to see which one's A, B, and C. So why don't you guys try plugging those in? Remember, C is the longest number, right? Okay, so try plugging those into your formula and check if it's a right triangle. Okay, so check your work on that one. Did you guys get the two numbers not equal? Yeah, okay. when you're doing this type of problem, I know that the problem asks for a yes or no answer, like is it a right triangle or not, yes or no. But if on the homework all you put is yes or no, I'm not going to give you credit. You need to show your work, which is like showing the setup in the equation and the steps, how you figured out yes or no. Does that make sense? Okay. All right. Any questions on anything that we've done today? Okay.